Now we're going to look at 2009, question 3, part A. Rather long-winded question, but if we go and have a little look and let's see what we know. What are they asking for? Well, it's up on a straight little cliff. We know the height of it. We know it's shot off at a certain projection at an unknown angle. And we know it's going to strike the ground. We are interested, first of all, in the time it takes to hit the ground in terms of alpha. And you're going to be used to this. This is often an intermediate part of some other questions. But as an added bit of fun, we need to show that the two possible directions are at right angles. So quick little sketch, let's see what this looks like. There's our cliff, there's our ground. It's shot off, initial speed 14 root 10. Okay, this cliff is 200 high. And one thing that might happen is this, where it's going to land at point P, which is 200 meters away. Excuse my scale. Now, we're giving a little bit of a hint here because the other angular projection is at right angles. So if one angle is within this quadrant up here, well, it's not going to go backwards, so it's going to go slightly down. So the other way that this might be shot is down, kind of fast and low. There we are. Kind of landing at this gigantic point P there. You get the idea. All right. Now we'll worry about how that comes out in the wash, but just so we can understand, this is what might be happening in reality. Okay. First of all, initial velocities. We'll break it into our components. In the x direction, 14 root 10 by cos of alpha. And in the y direction, 14 root 10 sine of alpha. All right, no harm to write these down just so we know we're clear and everything. All right, we're going to be able to solve this because we know a lot of stuff that's happening at point P where it hits the ground. We know the distance in the x direction is 200. We know the distance in the y direction, well, it's gone down, so it's minus 200. Again, good to write these out so we don't make small slips along the way. All right, let's look at what we have. We have velocities, initial velocities. We have s, we're asked for time, so we're going to use our equation s equals ut plus a half at squared. And a is, of course, gravity. So, time to get into it. Let's come up here and we'll deal with the s direction first. S of x is equal to u of xt plus 0, because we have no acceleration in this direction. That looks pretty nice. 200 equals 14 root 10 cos alpha t. We want the time in terms of alpha, so that's great. No unknowns here, so we'll just do a little bit of rearranging. So the time equals 200 all over 14 root 10 cos of alpha. There we go. That's not too bad. Part 1 done. Now, part 2, to show the two possible directions are at a right angle. So we're going to want to figure out a bit more about alpha. So we'll use the s of y direction equal to minus 200, that little fact. So sy is uyt minus g over 2, so half g. Remember, g is going down, so it's negative, by t squared. Okay, let's put some values into this here. Minus 200 equals 14 root 10 sine alpha t minus g over 2 t squared. Okay, now we're going to sub in t from up here. Minus 200, 14 root 10 sine alpha by 200 all over 14 root 10 cos alpha squared. Okay, don't jump ahead and try and get this multiplied out just yet. And again, even though it's tempting to start cancelling 200s, this is 200 squared, so we're going to go one step at a time. We will, however, knock out those two guys. All right, so let's get this multiplied out and this tidied up. Minus 200 is 200 times sine alpha over cos alpha. Why is that sitting in little brackets? Well, we know sine alpha over cos alpha is going to be tan alpha, so we might tidy that up later on. Minus g over 2, so we can actually, I can see we're going to multiply this out, so g over 2 is going to be 4.9. May as well get that one out now. All over 200. Now just in the middle of exam, do be careful. Mind your zeros, 200 squared, stick it into a calculator, it's 40,000. Okay, 14 squared, 196. Root 10 squared is going to be 10, so by 10 is of course 1960. Cos squared alpha. Okay, I have a suspicion that this is going to simplify ourselves down to something, but we can, yeah, we'll tie this up now. Minus 200, 200 sine alpha over cos alpha. Minus, okay, 4.9 by 40,000. And look at this, here we go, this is going to be lovely and tidy. Divided by 1960, and it's going to be 100. I'm going to leave this in brackets, because again, you may recognize that 1 over cos squared alpha is one of our key trig relationships, where we can flip it to 1 plus tan squared alpha. So for this next step, let's go and, well, we'll lose our hundreds there, just in case, because they're really bugging me. I know they're bugging you. Minus 2 equals 2 times sine alpha over cos alpha minus 1 over cos squared alpha. There we go. It looks a little bit happier and tidier. So turning to our log tables, we will see that sine alpha over cos alpha is of course tan alpha. This one's a little bit trickier because 1 over cos alpha is sec alpha, and 1 over sec squared alpha is 1 plus tan squared alpha. So 1 over cos squared alpha, 1 plus tan squared alpha. Putting those in, okay, using relationships. Minus 2 equals 2 tan alpha minus 1 plus tan squared alpha. Watch your brackets. Okay, bring them out of the brackets. Okay, that's a great place to go wrong there. I can see a quadratic building up here, so let's tidy everything up. We'll move this across to the left so it becomes positive. Tan squared alpha minus 2 tan alpha, end up with minus 1 equals 0. Okay, have a quick look always. Is there a nice tidy solution? And if you look close, you realize we're nearly at a tidy solution. If that was a plus, there, we'd have a nice tidy solution. So possibly have a quick little scan for errors, but in this case, it turns out there are no errors. This is correct. So we need to use the B formula. All right. So in this case, we know the tan alpha. Okay, we'll just write these out a little moment on the side. A equals 1, B equals minus 2, C equals minus 1. Because the place you go wrong with these ones is with your signs. So minus B, 2, plus or minus the square root of B squared, 4, minus 4AC, so it's minus 4 by 1 by minus 1, all over 2A, 2 by 1. So tan alpha equals 2 plus or minus the square root of 8 all over 2, which means that tan alpha equals 1 plus or minus square root of 2. Okay, so now we've kind of got this figured out a whole lot more. However, how do we deal with our perpendicular angles? Okay, so think of it this way. We have two angles. Tan alpha 1 equals 1 plus root 2. Tan alpha 2 equals 1 minus root 2. Just to lay it out a small little bit. Okay, I'm going to need a fresh page for this. So let's think back to junior cert. divide two lines, the slope is m1, and another line here. Okay, if m1, m2 equals -1, they're perpendicular. All right, nice little fact to know. So let's think of this in terms of a relationship. There's my angle, okay, angle alpha. Well, call that y, call this distance x. Slope is y over x, but the tan of alpha equals y over x. So slope and tan of alpha are the same thing. So therefore, if the tan of alpha 1 but the tan of alpha 2 equals -1, the lines are perpendicular. All right, let's test that out. So we have 1 minus 1 plus root 2, 1 minus root 2. That's kind of equal. That's multiplies as like a normal quadratic. 1 by 1 is 1. 1 by minus root 2 is minus root 2. Root 2 by 1 is plus root 2. Plus root 2 by minus root 2 is minus 2. Cancel, cancel. Equals -1. Therefore, two angles alpha 1 and alpha 2 are perpendicular. Ta-da!